Dear all, Namaste and welcome to today's English class of grade 10. Today we are in Unit 5, Science and Experiment. Okay, we are in English subject of course, but talking about science and experiment. And today we are dealing with reading fast. Reading yes, you can boil water at room temperature. Isn't that wondering? To listen, you can boil water at room temperature. Can we boil water at room temperature? Seems it's impossible to boil water at room temperature. But it is possible. The lesson says it is possible, then we will go through it and find out how water can be boiled at room temperature. Before that, we have some activities to do in getting started session. So let's go into getting started session. So here it goes, the getting started session. What can you see over here? Look at the pictures. Okay, we have some pictures. What do you think they are about? Obviously, we can see pictures, two different pictures, and they are about science. Yes, as our topic unit is related with science and experiment. Science is all about experiment, right? So science and experiment, these pictures are also related with that, or we can say, okay, they are scientific experiments. Okay, let's talk about this picture one by one. The first picture, okay, look at the first picture properly. What can you see over here? Yes, it seems that it is a lab, science lab, and we can see a girl, right? And a microscope. What is she doing? Yes, a girl is using microscope, observing something into it, right? Looking into microscope. Why do we use microscope? All of you know, right? Yes, we use microscope to see the organism, small organism that we cannot see with our naked eye. Naked eyes, we cannot see with our naked eyes, and we see that using microscope. Okay, let's move to next picture. What is there? Okay, you can see colorful water. Is it water? We don't know what is it, right? So it might be some solutions. Yes, since our unit is related with science, this must be solutions of scientific experiments. And what these tools are called? These are scientific experiments, scientific tools. And what these tools are called? Have you ever been to science lab? You must have been, right? And you must have seen these tools over there, haven't you? Yes, you have seen and perhaps used in scientific experiments in science subject. Okay, let's name them. Okay, let's name them. This first one, blue color solutions. The container with blue color solution is called flat bottom flask. What about this second container with green color solution? It is called conical flask. Third one, very easy to recognize, right? You have used so many times. It is called beaker. And the last one is called graduated cylinder. Okay, so all these containers are used to hold or measure, right? You can see measuring scale over here, right? Measure different kind of solutions in science lab. Okay, so this is the session we get acquainted with some scientific tools and some containers. Now we move to our reading session. We are in English subject, do not forget that, right? So we have reading text, we have to read the text and um, go along with that, right? Okay, we still some have questions. Reading I answer the following questions before we start the exact hour lesson. The first question is, what can you see in the picture? Okay, this is the picture given in your book, right? And one more additional I have brought over here. What's going on to show the process? What's going on? Yes, of course. Water is boiling. Okay, we can see water bubbles over here, right? Water bubbles, and this is also called water is formed with what does water form with? Yes, molecules, water molecules, right? Bubbles, water molecules. Okay, then next question is, how does water boil? How does water boil? Okay, so you might say that when we put water in the um, fire or gas, the water is boiled. The common people might say answer like this. But you have to tell the answer in the language of science. And when you give answer in language of science, we call it, we can say like this. Water boils when the vapor, what comes when we boil water? Vapors, right? Vapors come from there is equal to atmospheric pressure. Okay, water boils when vapor pressure and atmospheric pressure is equal. I have one more picture over here to show it, to clarify it. Okay, as we boil water, so there is evaporation. Evaporation, water goes up, right? What comes from there? Okay, evaporates. We can see water evaporating like this. And boiling is when there is equal pressure. You can see there's a friction in water molecules, and when there is friction and the pressure of external environment is same, boiling takes place. Okay, this is what boiling. And our today's topic is, yes, you can boil water at room temperature. So this is really wondering how we can boil water at room temperature. How it is, let's find out together. Okay, all of you stay with me and let's find out. Sometimes it's right on the box of rice mix, the high altitude version of cooking instruction. Okay, when you buy new cooker, let's say rice cooker, there are some instructions written on it, on the box. And what is written over there is, in the high altitude. What is altitude? The height of an object or point in relation to sea level or ground level. So high altitude, there is instruction about high altitude cooking. Usually this means that your rice will have to cook a little bit longer if you are in Denver or at the top of Mount Everest. Denver, okay. Denver is a place name, a Rocky Mountain from Colorado, right? Denver, a Rocky Mountain in Colorado. Here I have brought picture of Denver and Mount Everest. Mount Everest, okay, both pictures are here. So of course that's just a joke. Do we go to Mount Everest to cook rice? Of course not, right? It seems like a joke. No one cooks rice at the top of Everest, but why are the instructions even different? And why these instructions are given? Why does it matter where you cook? Does it matter where you cook? The answer has to do with boiling water, and it is related with boiling water. Okay, so in Denver, there is 16 degrees Celsius temperature is there, and in Mount Everest at the top there is minus 16 degrees Celsius temperature. So what do with this? What is the relation with cooking and the altitude height is given about in this first paragraph, right? So cooking in high altitude. The paragraph says cooking in high altitude takes longer time because it is because of boiling water. There is something relations with boiling water. Okay, next paragraph. You ask some people on the street about boiling temperature. So go and ask with people in which temperature water boils. Temperature, right? If you ask about degree or intensity of the heat of water, some might say it is 212 degree Fahrenheit, or even better, most of the people will say 100 degrees Celsius. Everyone knows that, right? 100 degrees Celsius, in 100 degrees Celsius water boils. But that's not always true. As you increase your altitude above sea level, so as you go up, okay, sea level, go up the sea level, the boiling point of water decreases. Boiling point is decreases by about 1 degree Fahrenheit. For every 500 feet increase, that means your water in Denver is going to be 203 degree Fahrenheit, and this will have an impact on your cooking. But why? So there is impact on our cooking as altitude goes up by 500 feet. By 500 feet, when the altitude goes up, and it has to do with something with what? Cooking, because the boiling point is decreases. That's why cooking time lengthens. Okay, next. Okay, this paragraph talks about altitude increases, boiling point decreases. Okay. Next one is water vapor pressure. Okay, what do we need to know is water vapor pressure. We need to know about water vapor pressure over here. There are many awesome things about water. One interesting factoid. What is factoid? Fact related to fact. Factoid is a piece of unreliable information that is repeated so often that it is accepted as fact. Habitual thing that we listen. So that is factoid. There are many awesome things about water. One interesting factoid that on the surface of the earth you can find water in all three phases: solid, liquid and gas. Don't we find? Yes, solid, ice cubes, and then gas form, when water evaporates, gas form you find over there, and then water, of course, liquid is water. So vapor is what? Gas form. We call the gas phase of water, that is vapor, right? Okay, so this is what about, okay, vapor is a substance diffused or suspended in the air, especially when normally liquid or solid. So from this paragraph, we come to know that water is found in all three forms: solid, gas and liquid on earth. We find water in different three forms in our earth. Then comes about this. Okay, You might think that you need to boil liquid to create water vapor. Okay, this is the point, what we are looking for in this paragraph. Main point, we are boiling water at room temperature, isn't it? We might think, because our internal thinking is what we need to boil water to create vapor from it. But you do not. You just need some liquid water at room temperature. Take some water, maybe picture a glass of water. Look at the glass of water. Take a glass of water. If you could zoom in with supervision, not actually possible, you would see that this water is made of bunch of molecules. Okay, we have picture water molecules. Okay, water molecules. Let me show you on the board. How do we write water in formula form? S2O, right? S2O. So this is made of one O and two H hydrogen. H, two hydrogen and one oxygen, O. So these separate R's atoms, and together it forms what? Together it forms molecule. Okay, these are molecules, two hydrogen. Although these molecules are themselves made of atoms. So separate, these are atoms, and two hydrogen, one oxygen. Two hydrogen, one oxygen. Let's just think them as tiny balls. Okay, if we think them as a tiny balls. Okay, so this paragraph talks about water is made up of three atoms, molecules. Okay, water is made up of molecules. Let's continue. These tiny water balls are moving around in the water but stay fairly close to their ball neighbors. So in the neighbors, close, they stay very close. This motion is not due to currents in the water. This motion is not due to currents in the water. Instead, this is thermal motion. This is called thermal motion. Thermal motion means refers to the random motion of molecules, atoms, electrons, or other subatomic particles. So thermal motion means it has spontaneous energy itself. When water has abrupt, sudden kind of energy it creates, that is thermal motion. Imagine these tiny balls jiggling. What is jiggling? Move here and there, jiggling in a giant collection of balls. The hotter the water, the greater the motion of these water balls. So we give heat from down, right? And hotter we give energy, hotter the energy we give, the water balls, they move very quickly, faster they move. All right, so water balls move greater when it gets hotter. After that, but wait, the speeds of water particles are not all the same. Okay, all molecules, they do not move in the same way. Although there is an average speed, a ball speed, average speed is there. Some are going faster, some are slower. It's just like the height of group of adult humans. Okay, example, they all do not move in the same speed. The average speed is there, but they do not move in the same speed, as there is an average height, but everyone is not the same, right? There is average height of people, but everyone is not of equal size, right? Some people are very tall, some are just a small fraction of a total group. So this is average, in average. Particle means atoms, separate atoms. These are particles. So the speed of water ball speed is average, not the exact. Then let's talk about, if you have a glass of water sitting out on a table. Okay, let's take a glass of water. The water balls don't stay as a liquid. So if we keep a water glass in our room, they don't stay as it doesn't stay as a liquid all the time. Some of these balls have enough thermal energy to break away and become free. So within the water, you can see the glass. You can, if you see it very closely, the water molecules, they start to change. They have some thermal instant energy potential in itself. They can self break down and they became free. Liquid stage, they come free from liquid stage, means water is now a gas. They changes into vapor itself, water vapor. Boiling is not needed to get this water vapor. So what is boiling? When we boil, vapor comes out of it, right? But we don't need to boil it to change liquid water to vapor. We just keep glass of water in our room and it, evaporates. Not all, those molecules which is very active, which has thermal energy. But wait, it works the other way too. Some of the water balls in the gas stage can interact with the liquid water and join the liquid water balls. So they interact and some joins again to the liquid, break themselves and become gas, and gas can form and become liquid. Let me show you on the board. Okay, if we keep a glass of water in our room, okay, some water they evaporates, right? Some evaporates, and some they evaporates, and also they come down. Some come down. So this is called some goes up, evaporates, and they become gas, and some gas again they come down and joins to the liquid. Okay, so this is what the process goes on. Okay, water in the closed container will eventually reach an equilibrium state between water vapor and liquid water. Okay, equilibrium state. What is equilibrium? This is stable and balanced. As we talked about, water evaporates. This is evaporation if water goes up as steam. And if we cover it, you can see in another beaker, it is covered and water, again the vapor comes down as the form of water. And if this process is equal, how much water goes as evaporates, steam comes down, the same amount of water comes down to the glass or the container, then that is called equilibrium process. Okay, state, equilibrium state. At this equilibrium state, the rate that water balls are freed from liquid state are same as the rate of water balls entering the liquid state. The rate is same. The gas pressure of this water gas in equilibrium is called the vapor pressure. The vapor goes up. This is vapor pressure. You can see this evidence in water vapor in a closed container by looking at the water and condenses on the water. Condenses, they comes back. Gas changing into water again. That is condensation, right? Condenses, compress, squeeze. So water vapor and liquid water in the balance form is equilibrium process. Did you get that? How water again changes into water? Water vapor changes into water? Yes, they can again changes into water. Then, okay, look at this boiling water. Here is what water looks when you get it to 100 degrees Celsius in slow motion. Yes, I think you have seen this before, but it's still cool. What are the bubbles in the boiling water made of? Okay, let's talk about what are the boiling water made of. Bubbles made of. These kind of bubbles are formed when we heat water, right? When water boils. Are the bubbles made of air? What about one hydrogen and some oxygen? No. The bubbles are water vapor. They are water vapor and they are small pockets of water in gas phase. They are vapors, water vapors, gas phase. I mean, they could not be air. Where would this air come from? The only option is the bubbles are made of water vapor. These bubbles, water bubbles, are made of water vapor. So, what is happening to make these boiling bubbles of water vapor? It's all about temperature, okay? This is all about temperature and vapor pressure. As the temperature of water increases, the average speed of water particles, what are the particles? Atoms, they are increases. At the same time, water molecules have enough energy to push back other water molecules in the liquid phase to form a bubble. So they struggle, there is a friction in the water molecules and they form water bubbles. But you have to have the water hot enough so that the particles are moving fast enough. So as the temperature of water increases, the speed of water particles also increases. Okay, I hope you are getting it right. But wait, it is also about the vapor pressure. In order to keep the bubble from collapsing, the pressure inside the bubble must be equal to pressure outside the bubble. So bubble is formed and inside, okay, look at the board. Okay, we have a water bubble, right? Water bubble. So pressure inside this water bubble and outside should be the same, not to break these bubbles. Inside the bubble is vapor pressure and outside is water pressure. So this means that for water to boil, the temperature must increase. Temperature must increase until the vapor pressure is equal to the outside pressure and a bubble can form. So what we can get from it is, as the temperature increases, water bubble is formed and we need same level of pressure inside and outside of the bubble. What about the external pressure then? That depends upon two things. First, the water itself. In order for the water not to collapse, the deeper water must have a higher pressure, and so the water pressure depends on the depth, the density of water and the gravitational field. Okay, so let's talk about the glass of water once again to understand this. Okay, so if we have glass of water like this, the pressure over here at the bottom of the pressure over here is more than top of the glass. The pressure is more over here, right? Because this pressure is due to the volume of water as well and gravity. Next thing is what? Gravity. Density of water and gravitational field. Due to that, the pressure is depend upon that. For a glass of water, pressure 2 centimeter below surface, 0.2. Okay, 0.2. In difference of 0.2%, the atmospheric pressure is different. Water pressure is different. The pressure is more here. That's why if you make a hole over here, the water comes out more forcefully than if you make hole over here, right? The pressure is more in the bottom. And this is the second thing, contributes to total pressure in the atmosphere. Same thing happens in the atmosphere as well. The atmosphere also pushes down the surface to the liquid to increase the pressure in the liquid. So same pressure is maintained in the environment as well. Okay, lower pressure. Let's talk about lower pressure. What if I decrease the atmospheric pressure pushing some liquid water? This would reduce the pressure in the liquid also. If I reduce this pressure enough, I can bring it down to the same level as the vapor pressure. Boom. Now the water particles have enough energy to form their tiny little boiling bubbles without the need to increase the temperature. Okay, so we understand this by one experiment. Okay, we understand this by experiment. So if atmospheric pressure is pushed down, if atmospheric pressure is maintained, the little water bubbles formed without need to increase in the temperature. Water bubbles can be formed without increasing temperature. So this is shown by one experiment over here. We will soon know that. I can even get water to boil at room temperature. Okay, this is what we are looking for really, right? Yes. You need a vacuum pump and a strong container to get this to work, but you can do it. Notice that I hold onto the boiling water flask just to prove that it's not hot. Trust me. Oh wait, you don't have to trust me. You can do it on your own. You just need one of the large plastic syringe. Get the syringe and put water in it with very little air. Seal up the end and heat up the water just a little bit. Here you can see my version. Okay, so you can prove it by a experiment. Okay, you can do you need a syringe for that, and fill up this syringe with little water. See here. Okay, look at here. A person is using syringe and fill up the syringe with water. I use hot glue and a rubber stopper along with Lego piece to seal the hole. The syringe was just heated about to 40 degrees Celsius, a little over 100 degree Fahrenheit. Now I can pull the plunger. What is plunger? Needle. Out to decrease the pressure in the liquid and induce boiling. Make boiling. Okay, see here, boiling is possible without the water bubble is formed without heating, without temperature, increasing temperature with this process. So it is pretty tough to pull the plunger back to increase the pressure, but you can do it. Oh, why heat the water up? Well, I cannot get the perfect vacuum by pulling the plunger, so I need a little boiling help by starting the water at a higher temperature. All right. So this is exactly what's going on when you cook rice at high altitude. Well, not exactly the same. There is not a human pulling back on a giant plunger that holds the air on the earth. So it's not the earth, earth's whole air cannot be held with the big syringe or plunger, right? So it cannot be done with like syringe, as he did experiment with syringe. Little water was put and it was pulled back to maintain the pressure, and then bubble was formed inside the syringe, right? So this cannot be done with the natural environment. The earth gravitational field does that for you. Okay, gravitation that maintains the pressure. So that is what the cooking. All right, so as a sum up, what we can sum up with this lesson is that it takes relatively longer time for cooking in high altitude, and this is due to boiling point. So as the height increases, boiling point decreases, and all three form of water is found in on our earth: solid, liquid, and gas. Water forms, they can keep changing. The form can be keep changing due to its thermal energy. We don't need to heat it. So water is made of water molecules, and atmospheric pressure is maintained due to gravitational force of earth. So what we can sum up? So yes, it is possible to boil water at room temperature. Mean the form of water can be changed itself by its thermal energy, and if we maintain temperature, right? Temperature, pressure If we maintain pressure, then we can see water bubbles, boiling bubbles without heating it up. So this is what our lesson is about. I hope you enjoyed and got today's lesson. Here I have got home assignment for you. Some words are there. Please use these words in your sentences of your own. Altitude, vapor, vacuum, temperature and molecules. So with this, I would like to say this much for today. Namaste.